here. And I love these forums because this is a forum where we get to share knowledge, because I am a person who is actually executing, and as the previous speaker said, he provides solution to my problems. So thank you, and it's really good to meet you. I'm sure we'll catch up later also. As I proceed, the mail that I got that I was supposed to speak on smart concrete and intelligent structures. So what does really smart concrete and intelligent structures means? I think he has already asked that question. Smart actually is something, if you ask from my point of view, anything that solves your problem, anything which is adaptive, which can adapt to your requirements, your, each problem is unique, each structure is unique. So the requirements are unique. So the structure, the solution, the concrete that adopts and solves your problem is a smart, and one which is responsive to your requirements is an intelligent structure. Before I begin, I'll just give 2 slides on the company that I'm working in. And I'm on deputation to RVNL. RVNL was a very new company. It was just formed in 2003, began operations in 2005. We got the Mini Ratna category in 2013. And we were granted the Navratna status in 2023. We were primarily into the railway infra, but from railway infra, now we have moved to global infra, because we have our presence in the highways, we have presence in the airports, and many other projects are being done worldwide now. This is the financial performance of the company. We have been, performing satisfactorily well at 20,000 crores turnover every year, with a PAT of more than 1,000 crores, and we have an order book of more than 85,000 crores today. The theme that we are speaking today or discussing today, smart concrete and intelligent structure, is very relevant theme at this point of time, at a time where the nation stands today, and when we think that what we are today and where we want to go 25 years from now. And that is because our Honorable Prime Minister has given a vision to the nation, and that vision is called Viksit Bharat. When we talk about Viksit Bharat means it's a vision of making India a developed country. So long, we have been just hearing India as a developing country. It's time for India to achieve the status of a developed country, and we have a vision to make that the country a developed country on the 100th year of our independence, that is 2047. And this vision focuses on very important, the first word is sustainable growth. More than smart, it's actually sustainable. We focus on the sustainable growth in every field. And when we are talking about our field, it's the field of infrastructure, and more so today's topic, concrete. So it's more than smart concrete, actually, it's sustainable concrete that we should be talking of. And when we talk, of course, the vision has the focus on social equity, global leadership, and is inspired by a roadmap addressing the infrastructure, economy, governance, and technology. This is the overview of where we stand today. India, our GDP today is $3.9 trillion. But this aim, in the next slide I'll show you, the aim is to make India a $30 trillion economy by 2047. And in today's economic times, if you read, Shri Piyush Goyal said that we should try and achieve a $5 trillion economy in next 3 years or so. And if we achieve $5 trillion economy, we are talking about taking over Japan, and we are talking about taking over Germany, which means in 3 years from now, we are talking about India becoming the 3rd largest economy in terms of nominal GDP itself. These are the milestones that we talk about. 2047, these are the sustainable development goals, and becoming a $30 trillion economy. And infrastructure has a very, very important role to play here. And
इंफ्रास्ट्रक्चर यानी लोगों के जीवन में आसानी, इंफ्रास्ट्रक्चर यानी व्यापार कारोबार में आसानी, इंफ्रास्ट्रक्चर यानी रोजगार के लाखों नए अवसरों का निर्माण, और इंफ्रास्ट्रक्चर यानी तेज विकास.
I can't explain it better than that. And this very sentences necessitate the need of intelligent structures and smart infrastructure. These are the goals, broad goals for the infrastructure that we have set, that the country has set for itself for 2047. If we talk about the roadways, 10 million kilometers of roadways. I'm from railways, so talking about high-speed rail of 10,000 kilometers. Right now we are having only the first project, Mumbai-Ahmedabad high-speed rail, but we are talking about 10,000 kilometers of high-speed corridor. The modernization, electrifying 100% of the railway lines, the freight corridors of 15,000 kilometers. You'll be pleased to note that probably in next year or so, we'll become the second largest country to have the, in terms of metro network. We'll very soon be overtaking the USA. But the gap between India and China in terms of the metro network still remains large. We'll be over something like 1,500 kilometers, and China is 5,000 kilometers of metro. The airport and the roadways. These are the, before I begin to talk about the other intelligent structures, smart concrete, etc., let me tell you what all important structures we have constructed in the recent past. One of the modern engineering marvels that RVNL has constructed and we have just commissioned is the new Pamban Bridge. It's the first vertical lift bridge of Asia, and the Honorable Prime Minister has recently inaugurated this. The old one was a Basicule bridge. Everyone knows it was partially, hampered in the cyclone of 1964. Dr. E. Sridharan was there who supervised the restoration, and the old one was a marvel. The new one is even better. This is a Bardwan cable stayed bridge. Why is it important? It was a smart solution to one of the problems. Why? Because traditionally we have, as you know, the railway lines are there in the most important cities. As the cities are growing, you have a lot of jams at the railway crossings. So these level crossings were to be eliminated. So when these big yards, I mean, you talk about big yards, I mean, every major city has a very big railway yard. So if you have a limited span of ROB over there, then it was posing two kind of problems. One, if you have small spans ROBs, which means there were pillars, there were piers in between two railway tracks, and that used to create a permanent bottleneck in the yard expansion. So there was a need that there should be a structure which should have a span long enough, but at the same time, the level, that is the difference from the top level to the bottom of the deck, top road level to the bottom of the girder, should be minimum, because most of them were replacement of existing ROBs, and there both the levels are fixed. The approach road level is fixed, as well as the bottom of the girder is also fixed because of the clearance from the rail level. So for that need, this Bardwan, we went for a cable stayed bridge which solved the problem, and then we are going for another cable stayed, another iconic structure is coming up in Howrah, that is called the Chandmari Bridge. The erection is almost complete, and very soon we'll be able to commission that bridge also. So that is a solution to these problems. Metro projects in Calcutta, RVNL is constructing two major lines in the city of Calcutta. The purple line runs from the Joka to Esplanade, which is under construction, which I'll be explaining in a bit detail. The orange line is from New Garia to airport. That is also on fast pace. We are trying to reach a city center 2 by March 26. A very important station, a smart structure, I would say, that we have recently constructed is the Rajarhat station. The problem of the definition, again, why I'm using the word smart or intelligent is, there was a very big problem in constructing this Rajarhat station when we were doing, because the station on this side, if you construct a station on this area, which is called the New Alipur or the Rajarhat area, is equally populated on both sides, which means both the sides of the metro station need to be given access. So if you plan on this side of population is devoid of the facility, and if you do this side, the vice versa happens. So what has been done is, it's a station over the railway yard. And in the Times of India, I did not have time to bring that slide here, but Times of India covered it. It is the first metro project, first metro station over the railway yard. So you see the down below, what you're seeing is the conventional railway, the railway lines of the Sialda division of Eastern Railway. And this is the metro station over the railway yard itself. The concourse is over the railway yard itself. And you see this is the bridge, the Rajarhat bridge, the road bridge, the cable stayed bridge here. And if you see this, there is a connection from the metro station to the Eastern Railway Sialda division station. So which means the suburban passenger can take these stairs and go to the metro station and take a metro ride, and vice versa. And just outside this Rajarhat station, there is a bus stand. So this is a kind of a first of a multimodal connectivity, a place in Rajarhat where you have the connection of the bus, the metro as well as the suburban transport. And this is what was conceived in Anand Vihar also, the multimodal transport, where the metro, the bus stand, the NCRTC, everything is at one place. And that is why when we talk about the national transport policy, they talk about a smart card. That is, every passenger should have a smart card, and that card should be valid across various modes of transport. That means the same card should be used for the buses, same card should be used for the metro, and same can be used as. So that is a thing we are planning, and probably it will be implemented. This is a recent breakthrough we had in Rishikesh Karnaprayag, another iconic structure and a project that is going on from Rishikesh to Karnaprayag, more than 100 kilometers of line. And first time the TBM has been used in the Himalayan geology here. And we have done the successful tunneling on the 14 kilometers here, and we have had the breakthrough last month. Now I'll tell you, talk about my project that we are doing here. One of the projects is this metro project of Joka BBD Bagh. This is the overall metro map here of Kolkata city. This is the purple line starting from Joka to Rajarhat here, and then going up to Esplanade, and Esplanade by the 3 metro stations merging into each other. In Joka BBD Bagh section, Joka to Rajarhat, the train is already it's in service, and from Rajarhat to Esplanade, the 3rd phase, we are constructing, and the underground metro project is, the underground construction is in progress, and the tunneling by TBM will start very shortly. This is the overall alignment of the underground metro project here. And what makes these metro projects actually sometimes time-taking or very complex is I could fit only these many, agencies here. These number of agencies, and probably double of it, they are to be taken together. The consensus has to be built, and then only you can move on. Example is, if you talk about a case study on this Joka BBD Bagh, we are making the entire, corridor now underground is going under the defense. So a lot of time taking in getting the approval from the MOD itself. Once you go there, we have structures, the heritage structures. So the permission has to be obtained from the ASI. We have, all the time you have to be in coordination with the PWD. We have to take traffic block from the police, the KMC, because the moment you talk about even piling or underground, Calcutta has a lot of underground utilities, mainly by KMC and many other departments also. So this utility shifting itself is a big project for the metro projects. We have, for the first, this Joka BBD Bagh project is the first project where we have planned transplantation of about 1,000 fully grown trees, apart from 5 times plantation that has been done. So taking care of environment, and again, that is a part of sustainable development and sustainable project. If you're talking intelligent project is the holistic package. It is not only about civil engineering, it is about the whole, the civil, the electrical, the signaling, the environment as a whole that you have to talk about. We required some land from St. Thomas School. We are very thankful to St. Thomas School. We are lowering the TBM from the St. Thomas School itself. I'll just show you a video. Of course, here there are a lot of court cases. So first you have to start the project, then you have to go to the High Court, then to Supreme Court, and then finally you start the work. So this is what makes, I would like to show you this video where we have taken an innovative step to transplant the trees, try and transplant the trees up, which in conventional way just used to be cut down.
In modern times, one of the challenges faced in planning infrastructural projects is maintaining a delicate balance between development and environment. The prestigious and technically complex project of Mominpur Esplanade Underground Metro in the great city of Kolkata also faced this challenge.
Excuse me?
In modern times, one of the challenges faced in planning infrastructural projects is maintaining a delicate balance between development and environment. The prestigious and technically complex project of Mominpur Esplanade Underground Metro in the great city of Kolkata also faced this challenge. There are approximately 1,000 trees in the alignment of the project. In normal circumstances, trees are felled by doing compensatory plantation. But in this case, RVNL not only did 5 times compensatory plantation against each tree, but also transplanted each and every tree without cutting a single tree. You heard it right. All the trees in this project have been transplanted. RVNL and L&T collaborated and prepared a detailed method statement to execute this work of transplantation in a scientific manner under expert supervision. The big and heavy trees are first trimmed to make them lighter and transportation ready. Then the soil near the tree is excavated. The roots of the trees are treated with special chemicals to enable them to retain moisture and nutrients during the process of transplantation. The tree is then extracted from the ground using road crane and loaded on a trailer to transport it to its destination. At the location where transplantation is to be done, a JCB is required to excavate the ground and a hydra is required to unload it from the trailer and plant it back. The tree trunk may initially be supported using ropes from the ground till the tree is firmly rooted in the ground. With extra care for a few initial days after transplantation, the survival rate of transplanted trees can be increased. Committed to sustainable development, RVNL.
So we think that traditionally the survival rate that we expect from transplantation is around 30%, but we are trying to achieve a transplantation rate, success rate of 60 to 70% by we have hired the best of the people in this, those who have done transplantation in Central Vista. So we are also learning this process, and that is why I am just circulating it everywhere so that in future also we don't cut trees, we transplant them apart from compensatory plantation. It is going to help the environment in a big way. Apart from, if you read any DPR, which is important for projects in India, the environment impact assessment is very important. And that is why the people, and environment impact assessment is only not in terms of carbon dioxide absorbed, release, etc. It is also about the people, how many people are displaced, how do you cater to them. So one of the problems that we were facing in this project was, this is a very famous place, everyone should be knowing in Calcutta, Shahid Minar. This is the a very old BC Roy market. So we needed to shift this BC Roy market to make the underground station. So these people have been here for many years, and this problem was left for more than 11 years. So we solved them in a unique manner that we have proposed a unique solution. We are constructing a temporary BC Roy market here, shift all these people here so that their livelihood is maintained, it's not disturbed. We'll construct these stations. So we came up with a technological solution. Instead of constructing the whole station in one go, the station has been divided into 2 parts. First, this part of the station would be constructed. The top slab is designed in such a manner that this whole market will come back on the top slab, and when this market comes back, the remaining half of the station would be constructed. And this way, the status quo is maintained. It's a win-win situation. The people also don't get displaced, and the project also gets completed. This is another thing we planned for the city. This is the old blue line, the metro line that is Calcutta's old first metro line of the country itself. This is the green line that is coming from Havda to Sialda that is going, and this is the purple line that is coming from Joka side, South Calcutta. So there 3 Esplanade stations will be constructed here. 2 of them are already operational, 3rd one is coming up. So this becomes more or less of like the Rajiv Chowk of Delhi. And now to have a seamless transfer, a common plaza to make this whole project, this whole structure an intelligent structure. The ease of traveling, a common plaza is being constructed here. That would enable a very seamless transfer of passengers from one system to another system. Also, this line is being extended, planned to up to BBD Bagh, new BBD Bagh station here near the Eden Garden, because Eden Garden did not have any dedicated metro station, and the line can be extended right up to here, where in future, if the city plans to have a water metro, because it has a very nice front, we can have a multimodal transport where you have all kinds of transport available at one place. This is where the common plaza is planned. We have started doing tunneling. We are expecting to start the tunneling from the St. Thomas School towards the Esplanade by in another 1 week's time. The TPM has been lowered. These are the various kind of TBMs that are used, and we have used EPB. That is, every TBM is selected based on the geology that we have. So in Calcutta, we have a very soft soil. So for that, EPB stands for Earth Pressure Balancing Machine that are used. In other areas, for example, if you talk about Mumbai side, there you have rocky strata. So many these days water lines are laid, and a gripper type of this gripper is used for the rocky strata. That kind of machine is used in Himalayan region. For example, we use the single shield TBM. So depending on your requirement, the TBM is selected. This is the alignment of the TBM, and this is the future of tunneling. This is, I saw in Germany and Connect. Now the tunnels that are made are not only for railway or roadways. It's talking about making a big, large tunnels dia, and in one tunnel you have the facility for the roadways. You also accommodate the railways. You also accommodate the metro, and more than that, you accommodate the water supply system, the sewage systems, etc. And this is the 18-meter dia TBM that they have made. In metro, the dia of the TBM is 6.3. The ID, what we call the ID, the internal finish diameter is 5.5 meter. But we have machines now which are 18 meters dias. Once you have an 18 meters dia, it can be compartmentalized, so you don't need to have a tunnel, new tunnel for everything. And many of your facilities can be accommodated in a single tunnel. So I'll just show you this, the lowering of a TBM that we have done, just completed, and about to start the TBM by next 7 days. I'm sharing with you what we have actually done, not what's written in the books. That's the metal shield of the TBM. It weighs 130 tons. The TBM has 3 shields. Each shield has more than 130 tons, and a 700-ton crane is used. And it's very rare in this country to have a 700-ton or 1,000-ton cranes. That's the joining of the shields once they are lowered. This is the cutter head that actually cuts the soil. St. Thomas School and the church. We are just working just beside the church. So that's 45 days of work I have showed you in 3 minutes. So the tunnel that we make is made of these rings actually, and you join these 6 rings and you get the tunnel. And this is how almost we have already cast 1/3 of the tunnel that we are supposed to build. We have an area called Santoshpur near Rajarhat where we have this casting yard. It's a very nice casting yard. I would in fact invite all of you to visit my TBM site and casting yard. It will be an enriching experience for you. It's spread in 12 acres of land there. And this is the underground metro station. And why I'm showing you these two things is because most of the underground metro projects are made of these two things only. There is tunnel and there is underground metro station. And both of them are concrete. So once you understand this, we move to the concrete. So it's a top-down construction that we do in this part of the country. For example, if you go to Mumbai again, I'm talking about in the high-speed corridor, if you see, I was seeing the Bandra Kurla complex station that is happening. I'll just show you in the slide. So there they are doing the bottom-up construction. They have that facility because it's a rocky strata. So they can actually go to the bottom level and then they can start constructing bottom-up. But here, because retaining the soil, it's a very soft soil, so retaining them is a very difficult process. So it's a top-down method where you construct the D wall. This is how you understand it. So this is the D wall actually, diaphragm wall we call it. So diaphragm wall is constructed first. Once the diaphragm wall is constructed, you have a rectangular form. Then you start excavating from here. When you start excavating, then normally there is a cushion of about say 2.5 meters for the top slab. You do that and construct the top slab. There are cutouts left in the slabs. From the cutouts, you enter the excavators down below, reach the concourse level, then do I missed one part. Once having done the diaphragm wall, you do the barrettes first. You do the barrettes, then you come to the top slab, then you do the concourse slab, and then you do the base slab. So basically, since you are coming from top to down, and hence it is called as the top-down method of construction. I'll skip this part, but this is what makes the process of construction as a smart. Because as I said, I showed you, we will be beginning the TBM from the St. Thomas School just beside the St. Thomas Church. That church is also called St. Thomas Church, and the Orphanganj Market, very dilapidated buildings. So basically, these are our eyes and ears, these instrumentation, these crack meters, that inclinometers, and this is a very detailed, it requires another session to discuss the BCS and the instrumentation, but this is what keeps us alert all the time. Based on this, the alert, what we call is the AAA values, the alert action alarm are generated, and it is very important from the safety point of view to monitor and maintain this. Now coming to the concrete here, we call the smart concrete. With my understanding, we initially discussed, if I ever, I don't have that much experience, small experience of 23 years, but we started in railways, say, M20, M30 used to be traditional railways, were considered to be good. Even the RCC boxes, most of the bridges, M35 concrete has been used. But the times are changing. We talked about the strength of concrete. We talked about, high strength concrete. M40, M50 was called the high strength concrete. Then we started talking about high performance concrete. If you see IS 10262, it says that M65 and above is the high strength concrete. Then when you talk about what is the difference between high strength and high performance concrete, the strength is, compressive strength of concrete is not the only thing. That's an old concept. As sir has already explained here, high performance means apart from strength, you're talking about durability. Durability is the keyword that you require. So durability, the performance over the, what is your, again, the resistance against the corrosion, that again depends on your durability. And now, as you said, I will show you a video. The sir was saying we have already achieved 150 MPa. How many of you have seen that? So I'll show you a video. I've tested the, I've actually broken the cube of ultra high performance concrete in front of me. Up to, I've taken it to 180 MPa. I'll show you the video there. So this is the M40 mix design that we are using in the diaphragm wall, construction diaphragm. Again, whatever I'm telling is again not from any book. This is actually what we are doing here in the Rajarhat S-Planet project. So M40 mein we are using the fly ash. Again, when we talk about smart concrete, environment, you talk about sustainable. Environment is a big thing, and the carbon footprint is very, very important. And if I'm not wrong, 1 ton of cement production accounts for nearly 0.6 tons of carbon dioxide, and 8% of the total global emission of carbon dioxide is due to the cement production. That's on the Google also if you want to, you can check that. So the one way of reducing the carbon footprint is to reduce the cement content by using the what is called as the mineral admixtures. Mineral admixtures would mean using silica fumes, microsilica, GGBS, the ground granulated blast furnace slag, and the fly ash. So for the in the diaphragm wall, based on the requirements that we have, you are using the fly ash here in the 40. This is the M50 mix design we are using for the tunnel segments, which I showed you the 6 segments that we are doing. So here we are using the microsilica. And because we are in the, this is an important, we are using the crystalline admixture in the diaphragm wall. It's not used in the tunnel. There the microsilica is sufficient. We are getting. Now in the railways, when I was doing the projects in railways, for example, the new line, gauge conversion doubling, there the specification was that the permeability of 25 mm was allowed. But in these underground structures, the specifications are stricter and only 10 mm is allowed. So when we are using this mixed design and we are doing the permeability test, we are actually getting a results of 4, 5, 6 mm, not more than that we are getting. This is again the, we tried for the base slab, one of the base slab we wanted to do, and we are doing another project in the city of Calcutta, and rather it's the Havda. It's called the Kona Expressway. People from the city would recognize. So luckily I'm blessed to be heading these 2 projects of Kolkata and Havda. So there also we are doing pretty well. In last 1 year we have almost done 600 piles there, and we have started the girder casting from today. Today the first girder of Kona Expressway is being cast, where we are using M60 concrete design. And when you are talking about such high strength concrete, the quality control is very, very important as to how you do it. So in what we are doing differently from what I used to do in my earlier railway projects, the water, when you are doing up to M30, M35, frankly speaking, only we were checking the quality of water. But we are talking about say M50, M60. The thermal gradient of the concrete is very, very important to be checked. And that is why we have installed a RO plant as well as chiller plant in the casting yard itself. So the water that is fed to the concrete for when we are mixing the concrete, the water is at the temperature of about 2 degrees centigrade to 5 degrees centigrade. And when we were doing concreting in the month of May, we were actually mixing ice in the chiller plant itself to keep the temperature of the pore temperature below 32 degrees centigrade. That is specified for concrete up to M60 grade there. In another, I will just explain you for M80 concrete, the pore temperature specified is 25 degrees centigrade. So there, when you are doing that kind of high grade concrete and with that kind of cement, then the even chiller plant does not suffice. There we had to install a ice plant. This is the site laboratory that we have established. Again, from the Jadavpur University, I would request, sir, you can any time bring your students here. They would be happy to see these facilities that we have here. The RCPT test of, sir was already telling about it. So RCPT test is being done there at the site. Of course, third party also did. Permeability test, very, very important. Most of them get it done from third party, but we have the setup in our own laboratory there itself, checking the permeability. This is the high performance concrete. In fact, this is the mixed design that is being followed in the National High Speed Corridor project, Mumbai-Ahmedabad. So there they are using microsilica as well as they are using GGBS there. And they are using the cement content. For M80 is just 375, but overall cementitious content is this one. So if you see, when they were doing, and just see this one. This is the Bandra Kurla complex station of National High Speed Corridor. So there if you see, this is the bottom slab that is being cast. Now if you see the size of a person standing here, I don't know if you can see from there, the thickness of the base slab is 3.5 meters that is being cast. So 3.5 meters would be something like from here to here. So you can imagine what 3.5 meters is, 12 feet of concrete, thick concrete. So there because, and they are thinking futuristically because this station is designed for, this station has already taken into consideration that a 90-meter height building will come on the station. So they are leaving a foundation for that 90-meter height building, a 22-storied building right now, so that in future it can come and the commercial exploitation can be done. So when they, so what do they do? How do they control the temperature? So they install the thermocouplers. So thermocouplers are installed. They are installed in our site also because when we do the top slab at certain locations, 1200 mm thick is the concrete. So we install thermocouplers to measure the thermal gradient. Here it is specified in this that there are two things, pore temperature and the core temperature. The core temperature there is specified in their contract itself. It says the core temperature will not rise beyond 65 degrees centigrade. So if the core temperature is not to rise beyond 65 degrees centigrade, then even though the pore temperature is specified, that is on the outer periphery as 25, it was not working out. So the chiller plant was also not working out. Finally, the pouring that concrete for M80 is done is at 16 degrees, 17 degrees centigrade. And for that, there is an ice mixing plant attached to the swing setter full batching plant. So there the correction is done there. So unfortunately, I could not put the photo of the ice plant, but then you can see it on the Google. So the ice plant is attached to the wave batching plant itself and ice is used. But I'll show you why ice is required when you go beyond M80 also. So this is what we are talking about, the high speed concrete. That's me visiting the, the project and their lab. Now this is the ultra high performance concrete we are talking about. We are from M60, M80, now we have moved to concrete where we are talking about M150 grade of concrete. Just let me show you a video and then I'll talk about it. This is one of the facilities in Pune. I'm not promoting taking anyone's name, but I personally visited to see, because seeing is believing. I mean, when you talk about 150, it was difficult to say that yes, it is being produced. So I wanted to break cube in front of myself. And when I did that, I'll discuss. Mumbai-Pune missing link. So as the time is short, I'll just rush through. And if you see here, there is no coarse aggregate here in the mixed design. But see the cement content as high as 980 kg they are using, silica fume 120 kg. And the water cement ratio there is actually 0.17. So I agree with sir what he was saying, 0.17 sir, we don't find any problem these days. Yes, there are various literatures from which I have also read 0.23 was somewhere, 0.28 somewhere, 0.18 also somewhere, but they are 0.17, they are mixing, producing, and Morth has issued, I mean this guidelines, Morth has issued the guidelines, and recently RDSO has also issued the guidelines. This is going to be a big advantage. We are testing it, still in the testing phase for us, because imagine re-girdering for the railway projects, the weight of the girders is tremendously reduced, so the requirement of cranes can be tremendously reduced. So there, instead of, there is no conventional reinforcement in this, it is the steel fibers that are used in the ultra high performance concrete. This is the testing done, that I personally broke the cube, and when you break it, this is how you see the steel fibers here. Another three things that we have promoted, we have come the 3D printed concrete. Time is short, so I'll not show you the video. Yes, it is being done, many places have done it, and this is a RVNL conventional center which we have planned at Rajarhat itself and 3D printed. So when we do that, I'll invite you to come and see. This is, of course, I'll show, there is an experience center that we have made at at the Victoria station. I'll invite all of you to see, come and see. It has been appreciated by the Cabinet Secretariat, Secretary Coordination who has come. So you can just come and visit anytime. So this, most of the dignitaries have come. That's the CMD of RVNL, that is Sri Rajesh Moghe, the GOC Bengal sub-area. That is the General Manager Metro Railway. This is the DFCCIL team. This is the team, defense team from College of Defense Management. And this is last I want to say. I am a student of science, did only my graduation, did not do any masters or PhD, but I love technology and love to promote new technology as and when I see it. Because as he rightly said, the illiterate of 21st century will not be those who don't learn, need to, who don't know how to read and write, but who cannot learn, unlearn and relearn. This is what the way to go forward. Thank you so much. And I would also like to mention just one line. If you ever happen to Rajarhat, again I would invite, it's a state-of-the-art station. We have introduced the CBTC, that's called the Communication-Based Train Technology, and by which I mean in common language, a driverless train. So it has been first line that we have commissioned in Kolkata is the orange, this purple line from Joka to Rajarhat. Thank you.
Thank you. Okay, you can discuss any questions later, because I think he has some phone call and he has gone out. So with this, I just concluding this session now. Our next session will be starting after this.
After this or after this? We'll have a tea break after this. So we wanted to give the